We have arrived at today's AI marvels, from the early AI's basic rule-based systems. This was a fascinating journey. It all started with the dawn of rule-based systems, considered the very nascent stage of artificial intelligence. Imagine a system, one that is meticulously programmed to follow a set of instructions, also termed as rules, to the perfection. This is the fundamental premise of what a rule-based system is. A rule-based system is a specific type of artificial intelligence that is designed to solve problems by leveraging a set of predefined rules. For you to understand it better, let's take an example from the world of chess. A rule-based system in this classic game might contain a straightforward rule like, if the opponent's queen poses a threat to your king, move the king. Sounds simple, right? These rule-based systems function by applying these predefined rules to the data they are fed with, making decisions based on the different possible outcomes of these rules. The of rule-based systems lies primarily in their explicitness. They are clear, transparent, and easy to understand. The knowledge they contain is represented in these transparent rules, making it quite simple to deduce how the system is taking decisions. Feature comes in handy in scenarios where transparency is not just a luxury, but a requirement. However, like any other system, rule-based systems too have their limitations. While they shine in tasks that have clearly defined rules, they falter when there's enough uncertainty or change involved. This lack of adaptability is a significant drawback. Rule-based systems are only as good as the rules being given. They don't have the capacity to learn or adapt to new circumstances. If a rule doesn't account for a particular situation, the system may falter or even fail. Another hitch is their inability to deal with large volumes of data. As data increases, rule-based systems tend to become more complex and challenging to manage. This is primarily because every new data point might require the introduction of a new rule. Lastly, they lack the capability to learn from their errors or improve over time. Once a rule-based system is programmed, it remains static. It doesn't possess the capability to learn from past experiences or make improvements based on fresh data. From these humble beginnings marked by simplicity and limitations, the journey of AI took a fascinating turn toward the complex world of machine learning. Machine learning, a leap from rule-based systems, started to shape the AI we know today. Essentially, it's a type of AI that allows machines to learn from experience rather than from pre-programmed rules. This dynamic learning means that systems can enhance their performance on tasks incrementally as they process more and more data. Machine learning is a broad field and can be divided into two categories: supervised and unsupervised learning. Supervised learning involves machines being trained on labeled data. This data is provided with correct answers or outcomes, much like a student learning under a teacher's guidance. The machine then learns to predict results based on the training data it has been exposed to. Unsupervised learning, on the other hand, means training on unlabeled data. The machine discovers patterns and relationships within the data without any prior knowledge of potential outcomes. It's akin to a student studying independently, interpreting information without any predetermined guide. A major component of machine learning is the concept of neural networks. These are computing systems modeled after the human brain, consisting of interconnected nodes or neurons. These networks are designed to identify patterns and learn from data, making them highly effective in handling complex tasks such as image recognition and natural language processing. Another important concept in machine learning is reinforcement learning. In this type, an AI agent learns to make decisions by interacting with its environment and receiving rewards or penalties based on its actions. It's similar to training a pet dog, where good behavior is rewarded and unfavorable behavior is discouraged. However, machine learning has its own set of challenges. It necessitates large volumes of data to operate effectively. Moreover, the decision-making process of these systems can often be unclear, leading to black box problems, where the processes inside the machine learning model are not easily understood. Yet, even with these limitations, machine learning remains a potent tool in the AI landscape, revolutionizing industries and heralding new technological possibilities. As machine learning continued to evolve, it paved the way for deeper, more complex systems. Deep learning, a subset of machine learning, has brought about extraordinary changes, heralding early achievements that have set the stage for further advancements. This field is a fascinating intersection of computer science and neuroscience, mirroring the intricate workings of the human brain. The power of deep learning algorithms lies in their capacity to decipher features directly from data, taking inspiration from the human brain's unique structure and functionality, making them a vital tool in the tech world. This unique ability arises from a layered architectural approach where signals pass from one layer to another, each layer progressively learning to detect increasingly complex features. Imagine these layers as building blocks, each one adding a level of sophistication, teaching the algorithm to understand and interpret the world in a more nuanced manner. Such a mechanism has become critical to how deep learning has revolutionized a multitude of technologies, especially in the realm of computer vision. Just imagine a future where machines can interpret images just like a human can. Picture an automotive industry where deep learning ensures safer driving experiences, healthcare system that delivers personalized treatment plans. This is the brave new world that deep learning is crafting, a world where machines understand and learn from the world around them. Yet it's important to understand that its applications extend across transforming everything from farming to retail, optimizing processes and enhancing user experiences. But like any powerful tool, this technology isn't without its challenges. It requires vast volumes of data, significant computational power. Often, its operations aren't entirely transparent. This lack of transparency can lead to black box models, where the workings of the algorithm are hidden, making it difficult to interpret its decision-making process. Deep learning, while revolutionary, does have limitations, paving the way for the emergence of large language models. In our quest to delve deeper into these large language models, their strengths, their weaknesses, and the transformative ways they are changing our world, we will explore how they are adding a new dimension to machine learning and how they promise to usher in the next era of technological advancements. So stay tuned. Generative AI models, specifically large language models, opened doors in the AI world. This marked the era where AI started comprehending and imitating human at an unmatched level. Large language models, LLMs, are a subset of deep learning models, taught on a colossal amount of data to interpret and create natural language. As these models train, they learn language's depth, subtleties, and complexities. The outcome, AI that can produce anything from poetic prose to scholarly dissertations with remarkable skill. An essential component of these models is a system known as transformers. In AI terminology, transformers handle context-understanding language using a technique called attention. This technique allows the model to concentrate on different parts of the input while generating the output. They understand that when we say, "I left my heart in San Francisco," we are being metaphorical, not literal. Transformers are versatile. They power the autocomplete feature your emails, manage instant language translations, and generate chatbot responses that can often seem unsettlingly human. Yet these amazing abilities come with complications. One such problem is hallucination, where the model generates data that wasn't part of the training data. For instance, asked to describe a non-existent book, an LLM might craft an elaborate tale, filled with characters and unexpected plot twists. While this can be captivating, it's also a cautionary note that LLMs can create unreliable content. They don't understand, they mimic patterns they've learned. Multiple attempts have been initiated to address these issues, ranging from enhancing the training data to developing methods to verify the AI's outputs. The question persists: how do we ensure that the AI's creativity doesn't affect its output's accuracy? LLMs may have brought us closer to human-like AI, but they're just one facet of generative AI and come with unique challenges. Despite this, their creation was a major milestone towards the goal of developing AI that can truly comprehend and generate human language. Like any captivating story, the journey of AI continues to unfold, with each new chapter more thrilling than the previous one. Generative AI, the next frontier in AI evolution, promises to address the limitations of large language models. What exactly is generative AI, and how does it differ from its forerunners? Let's explore. Generative AI models are akin to imaginative artists in the AI realm. Unlike previous AI technologies, which are reactive, responding based on learned patterns, generative AI is proactive, creating new content from a blank canvas. It's as if we've given AI the power to dream. These models, such as GANs or generative adversarial networks, employ two AI systems pitted against each other. One, the generator, fabricates content, while the other, the discriminator, assesses the content's quality against real-world examples. Thus, the generator learns to generate increasingly realistic content through this creation and critique process. Generative AI's potential to address LLM's flaws is significant. Remember how LLMs often generate unreliable or nonsensical information? Generative AI, with its ability to create, not just react, provides a solution. It offers enhanced flexibility and creativity, paving the way for a multitude of applications. However, it comes with its own challenges. The creativity that makes generative AI potent can also result in unexpected, sometimes undesirable outcomes. That's why relentless research is underway to refine these models, aiming for heightened reliability and accuracy. As we dig deeper into generative AI, we're constantly learning and improving, uncovering ways to leverage its power and mitigate its risks. And this is an electrifying time in the AI realm. As we continue to tackle AI's challenges, the future is unpredictable. One thing is certain, the journey of AI evolution is far from over.